Okay, so our last assignment in chapter 4 talks about arithmetic sequences. Some of us got to talk in class today a little bit about this. And we talked about finding what comes next. And you said, oh yeah, I remember that. All right. So let's say if I had an arithmetic sequence of, say I've used number 5, 10, 15, and I asked you what came next, you would say, I can't hear you. What did you say? Speak a little louder. What comes next? Awesome, right, 20. I appreciate you speaking up. All right. And then I could take this and I could go on. All right. And what I'm going to introduce to you is now, as we talk about those, I'm going to talk about a new position or a new term if I were to carry this out. All right. And so this you're very familiar with. But now I'm going to give these names. All right. So this 5 is in what we call the first position. All right. This is in the second position, obviously. This is the third. This will be the fourth. All right. So each of these have a position. All right. And if I were to carry this all the way out, and let's say I wanted to take this all the way out to an unknown position. All right. We call this here the nth position. Yes, here we go with more letters. So we call this the nth position. All right, as we look at our sequence of numbers, first, second, third, fourth. And if I went out to an undetermined amount, it would be the nth. We would be solving for that position in the sequence. All right, so let's talk about, I want to talk about, explore, how do I find what that is? All right, so there's different types of sequences. One of them is called the in the arithmetic sequence, we look for the common difference. So I'm going to erase some of this here. All right. And I want to talk about the common difference. All right. So if I was looking at what was happening from here to here, or here to here, and so forth and so on, what you would tell me is, hey, they keep adding 5. That's all we're doing, is we are adding 5. All right. So then you could tell me the next 3 terms in the sequence. All right. So if we kept adding 5, my next 3 terms in this one would be 25, 30, and 35. All right. Sometimes, however, in those sequences, we could have numbers such as -7, -14, -21, -28. And I could even, I'm going to erase these extra ones here so that I can have room to write. What I could do with these is I can actually put these in a box. All right. And these here, this bottom number would be my terms. All right. And this would be the position of my terms. So this will be the first position, this will be the second position, the third position, and the fourth, and so on, just like we did here when we said this was our first, our second, our third, our fourth, and our nth position. Okay, and what seems to be happening here? Well, these numbers are getting lower. Okay, if I go from here to here, what is happening is I am subtracting 7. All right, so the position or the change in the terms, no extra credit, don't even try it, is I am subtracting by finding the difference of a -7 each time. All right, so if I did here, I could ask you, hey, what's the next 3 terms? And you say, oh, well, Mrs. Guerin, that's easy. You're going to have -35. Then you'd have -42 and -49. Okay, these are all multiples of 7. All right, so easy enough. All right, I want to talk about what happens when I have fractions. All right, no one likes fractions, so let's talk about when we have fractions. All right, so here I have some arithmetic sequences here, and I've put some fractions in. So what seems to be happening here? All right, as we go on, I like to think of fractions as money, and if you look at it, it's getting smaller. And each time that it gets smaller, so since I like to think of this as money, which you all know, I would call this $4. 3 3/4, some of you all know is $3.75. 3 1/2 would be $3.50, and 3 1/4 would be $3.25. So that may help you a little bit with the fractions. But if you notice, how much is the change each time? All right, so we tend to be dropping by 1/4 each time. All right, so as I go from here to here, I seem to be going down 1/4. All right, so 1/4, which is the same as 0.25. All right, same thing here. You're just constantly decreasing by 1/4. All right, so if we went down by 1/4 here, what would be our next term? A little louder. What would be the next term? 3. You're absolutely correct. Would be our next term. And then what would be our next number in our sequence? If we had $3 and we spent 1/4, we'd have $2.75, or 2 3/4. All right, so let's look here. All right, this seems the same thing's happening here. I got 20 cents. I like to think of decimals as money. If I go from 20 to 60, how do you go from 20 cents to 60 cents? Right, you just add 40 cents. And how do I go from 60 cents to $1? Correct, I'm just adding 40 cents. All right, so what would be the next sequence? You're absolutely correct, 1.8. And then my next one, 2.2. Very good. So I think you have the hang of it. And I want to move a little further in the lesson to talk about how we could graph these sequences. All right, so let's see if I wanted to say graph a new sequence. And so we have our graph quadrant here, and we're talking about how do we graph information. And I'm going to actually, I want to take a look at your student journal just so that you can have a precise way of looking at this picture. All right, so if you're in your student journal and I'm going to say we're on page 119. Uh-oh. Okay, so number 7 in your book, in your practice book, there in your student journal, asks you to graph an arithmetic sequence. All right, and all they give you is some numbers here. So you're like, hey, how do I graph this? I need 2 numbers. Okay, so let's get your 2 numbers. All right, what I'm going to do is I'm going to create a table. All right, and the numbers that have been given us to graph are 1, 3, 5, and 7. All right, so these are the terms that have been given to us. And if you recall earlier, I said terms had positions. All right, so this is in the first position, this is in the second position, this is in the third position, this is in the fourth position. So now I have what looks very much like coordinate points that I can plot. All right, so my first one that I would plot here would be 1, 1. So I can put that right here. All right, and that would be 1, 1. All right, then I have 2, 3, so I can go over 2 and up 3, 1, 3. And that is 2, 3. Then I have 3, 5. And then 4, 7. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. And that's really all there is to plotting or graphing an arithmetic sequence. Okay, so keep in mind, arithmetic simply the terms keep adding, the consecutive terms add the same amount. So here, if I look at here, I have plus 2, plus 2, plus 2, and that's how we know it's an arithmetic sequence. All right, try number 8 on your own. I'm going to pause the video. If you pause it here, try number 8 on your own, and let's see if you get the answer correct. All right, so let's see what we have here. In example number 8, I went ahead and I put my terms, and then this is the order that they were given. They were actually given us to them. It's like 9, 6, 3, 0. So I've put them here. This is my first term, my second term, my third, and my fourth term. So I've put those numbers here so I have my coordinate points. My first one is 1, 9. So I'm over 1 and up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I have 2, 6. I'm going to go over 2 and up 6. 1, 2, 3, 4, 5, 6. This one's 3, 3. 1, 2, 3. 1, 2, 3. And the last one is 4 and 0. 1, 2, 3, 4. All right, and that's the way we would plot those examples that you have here. All right. All right. I'm going to move on to page 120, where we talk about determining if a graph represents an arithmetic sequence. How do we know if a graph represents an arithmetic sequence? All right, so the question asks is, how do we know if it is an arithmetic sequence? All right, so remember, if I said earlier, arithmetic sequence if the consecutive terms have a common excuse me, common difference. All right, so let's look at our consecutive terms. So my first term is 0. My second term is 1. My third term is 4. And my fourth term is 9. All right. All right, remember we said these are the positions. And these are the terms. All right. All right, so let's find the difference between the consecutive terms. The difference between 0 and 1 is 1. The difference between 1 and 4 is plus 3. The difference between 4 and 9 is plus 5. So these are not the same. Therefore, this here is not an arithmetic sequence. All right. We'll do a couple more, not this example, but we're going to do a couple more, and then that'll be it, and you can get started on your assignment. All right, so we move through our journal. We come to the portion where it takes you to write an equation for the nth term of the arithmetic sequence. All right. So please make sure off to the side of these problems somewhere, write down the equation. All right. Write down this equation. So we have a n minus a1 equals d, and then in parentheses n minus 1. All right. So it looks a little complicated, but it really isn't, in order to find the nth term of the sequence. All right. So here I have these numbers here, and we're just going to pull some information. All right. These numbers here represent what term I am looking for. All right. So these represent terms. This is our nth term. This is our first term. So in this equation, I want to find my first term. Well, this is my first term. All right. So the way we would write this is a n minus, and in this case, it is negative 5.4 equals. Now what I need to find is the difference. All right, well, we have d. It just means what is the difference between each of these terms. So what is happening here? What are we subtracting in order to get from place to place? All right, how much are we subtracting? How much further are we going? All right. So in this case, the difference between 540 and 620 is 1.2. It's actually negative 1.2. All right. And then n, what number are we looking for here? What are we going to substitute for n? Okay. So this is where we pulled all the information. We need the 5.2, and then the other information that we needed. We needed to know the distance, or the difference between these two numbers. All right, which happens to be 1.2. All right. So at this point, we're just going to carry out and do the equations just like you've always done. All right. So negative times negative In this case, we now have an plus 5.4 equals, I'm going to multiply negative 1.2n. I'm going to distribute here, plus negative times the negative is negative is a positive, and then we need 1.2. All right. Now, once again, all we want to do is solve this equation for n to find our distance. To find our nth term. Okay, and since we're solving for the nth term, we don't really know what term we're looking for. All I really want to do is just get this here that represents the nth term on the equation by itself. All right, that's all I really want to do. So I'm going to start by subtracting 5.4 from both sides. All right, there's no variable here. There's a variable here, so I'm going to subtract it from here. All right, line up our constants together. All right, and once we do that, this cancels out. And I'm left with a to the nth term equals, all right, and if I do the math, I'm just going to bring this down, negative 1.2n. The signs are different. I find the difference, and the distance between these two numbers is negative 4.2. Right? And that's how I would find the nth term. That becomes important because once we get this, sometimes there's an extra step, as it is in 16. Okay? 16 now asks us to find a 10. All right? The second part of that definition says find a 10. So in other words, when we are looking for our 10th term, all right, how do we find it? Well, that becomes very easy because now all we really are going to do is substitute, all right, that value in place of both ends. 1.2 times the 10th term minus 4.2. All right, and if we carry out all of that math, what we will find out is that our 10th terms, once we do the math, will actually equal negative 16.2. All right, now I'm going to go ahead, I'm going to do the next one simply because I ran out of space on this and it's a little sloppy. All right, so I'm going to do number 17. All right, so let's go through 17. I'm going to go through this very slow. I realized the first one was kind of fast. All right, but we're going to go through. So first thing I'm looking to see is, do I have an arithmetic sequence? Well, I need to find out what is the difference that's going on. So what is the change here? All right, so that seems to be minus 5, minus 5, minus 5. So I do have a constant rate of change, so I can go ahead and solve my problems. Once again, don't forget the formula. Okay, our formula says an equals our first term let me write it. There's a couple of different ways to do this. All right, here we go. I'm sorry. There's a couple, and I have a student who loves the second way of solving this problem. So I apologize. an minus a1 equals the difference times n minus 1. All right. So here we go. All right, so here we have our nth term, our first term, our difference, and n minus 1. All right, so we simply write that as an minus our first term, which happens to be 43, equals our distance, difference is -5 times n minus 1. Okay, so let's move on and let's solve this and see what happens. All right, I'm going to do my distribution. -5n plus 5. Bring down my equal signs. an minus 43. At this point, because I want to get an all by itself, I'm going to add 43 to both sides. And remember, we're adding them at the location where there's only a constant. We're not putting it under this one, which represents the term we are going to be solving for. an equals -5n plus 48. All right, so now I have my equation. All right, so this is our equation. All right, now they ask us to find, your book asks us to find a 10. All right, so all we're going to do is take this 10 and we're going to substitute it. That's all we're doing, just finding out the A10. All right, so the second half of our problem says that A10 equals -5 times 10 plus 48. All right, so if we do our distribution, -50 plus 48. All right, the signs are different, so I find the difference. The difference between these two is 2. The larger number is negative, so it's -2. So our 10th term, if I were to finish writing this sequence out, would be -2. All right, I'm sure you're going to have questions. Like I said, we're not going to rush through consecutive terms. Take your time and do the best that you can.